Hi, I'm Bob. Welcome back to the 5 Minute Econometrics, an econometric tutorial for basic concepts and methods. Today, we will explore the matrix form of the regression models. What is the matrix form of the regression model? A matrix is a particular arrangement of numbers. The sample used in a model is also an arrangement of data. Therefore, a matrix is suitable for representing the data used in the model. The most familiar way is the individual observation form. Suppose there were two explanatory variables x1 and x2. We write the i's observation as yi equals beta 0 plus beta 1 times x1i plus beta 2 times x2i plus epsilon I. I is from 1 to n. The expression represents the i's observation, so this is an individual observation form of the model. If we want to represent all n observations in one expression, we can use the matrix form. Before that, let me briefly introduce matrix and vector. An n by k matrix has n rows and k columns. The elements in the first row are A11 to A1k. The first subscript denotes the row and the second subscript denotes the column. For example, A11 is the element in the first row and the first column. The element A2k is in the second row and the k column. A vector is a special type of matrix with only one column or one row. An n by 1 matrix is called a column vector and can be written as follows. A 1 by k matrix is called a row vector and can be written as follows. As I mentioned, a matrix or a vector is a particular arrangement of numbers, and the sample we use in regression model is also an arrangement of data. It is suitable to write regression models in matrix form. Let's look at this sample of US workers' wages, years of schooling, and gender. We have 10 observations for 3 variables. The data are in the matrix form. Suppose we regress the log wage on schooling and female. We can write the explanatory variables and observations in a matrix X. We have 10 observations, so there were 10 rows. There were 2 explanatory variables, but we should add the ones for the intercept of the model. So the explanatory variable matrix X has 3 columns. It is a 10 by 3 matrix. We can write the outcome variable Y as a 10 by 1 column vector. We can write the population coefficient beta as a 3 by 1 column vector. The error term is a 10 by 1 column vector. Here is the matrix form of the regression model. If we write the matrix out, we find 10 observations. Each observation can be written as an individual observation form. Since we have learned vectors, the individual observation form can also be expressed using vectors. We write a row vector xi prime to represent all the variables in the i's observation. The row vector xi prime multiplied by the column vector beta equals a scalar or a number. And we know yi and epsilon I are just numbers. In summary, we have three ways to express a regression model: individual, observation, and matrix forms. Take the model with two explanatory variables as an example. The first way is for the i's observation. The second way uses the row vector and the column vector. It is also for the i's observation. The third way uses the matrix and vectors to show all n observations. We can expand it to the case with k variables. In that case, the explanatory variable matrix X will be a n by k plus 1 matrix. Thank you so much for watching this video. See you soon on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.